So let's begin this question by finding x. We'll use the Pythagorean Theorem. We have x squared plus 3 squared equals the hypotenuse c squared, which is 5 squared. We have x squared plus 9 equals 25. So therefore, x squared equals 16. Taking the square root of both sides, we have x equals 4. It's good to memorize the Pythagorean triple, 3, 4, 5. So we might just know right away this is 4. Now what is sine theta? Recall SOHCAHTOA. Sine is opposite over hypotenuse. So sine theta is opposite, which is 3, over the hypotenuse, which is 5. Now what is cos theta? Cos theta is adjacent over hypotenuse. So the adjacent is the unknown side, which is 4, which we solved previously. Adjacent over hypotenuse is 4 over 5. Now what is tan theta? Tan theta is opposite over adjacent. So tan theta is opposite over adjacent, which is 3 over 4. Now let's find theta in degrees. We can use either fact. We can start with sine theta, cos theta, or tan theta. It doesn't really matter. Let's just try the first two. Recall that sine theta was opposite over hypotenuse, 3 over 5. You can just look for that button on your calculator. You hit the sine inverse button. Sine inverse does not mean sine to the exponent -1. It's just a button on the calculator that gives you the angle. So theta equals sine inverse 3 over 5, which is approximately 37 degrees. Now let's try cosine theta. Cosine theta we previously found was adjacent over hypotenuse, which was 4 over 5. Taking the cosine inverse of both sides, we get theta is equals to cos inverse of 4 over 5, which is approximately, using your calculator, the exact same answer, 37 degrees. Now what is the meaning of theta equals sine inverse a over b degrees? We know that sine inverse is referring to the actual angle theta, so we just need to find theta. Now we're being forced to use sine inverse, so this relates to sine theta. And we did it already up here. Theta equals sine inverse 3 over 5. So A is 3 and B is 5. So remember that sine inverse refers to an angle.